Now that we've talked about big data, let's talk about something that every single one of you would have heard about in some form or the other. What is machine learning? Every single major branch that we'll talk about in this module is a subset of artificial intelligence. AI is a very broad general term in that it includes any technique that enables computers to mimic human intelligence. Machine learning, on the other hand, is a subset of artificial intelligence which includes techniques that enable machines to improve at tasks with experience. It gives computers the capability to learn without being hard-coded or explicitly programmed. So how exactly does machine learning work? The entirety of machine learning revolves around different types of algorithms and techniques. The machine learning process starts with the input of training data into a machine learning algorithm. Of course, the type of training data that is being input does impact the algorithm, and that will be covered in the next clip. Now, whenever input is provided to a machine learning algorithm, it returns a result value of predictions based on the model. If the prediction is accurate, it is accepted and the algorithm is deployed. But if the prediction is not accurate, the algorithm is trained repeatedly until acceptable results are reached. This enables the machine learning algorithm to continually learn on its own and produce the optimal answer, gradually increasing in accuracy over time. Machine learning is something that is fairly involved and complex, and hence it has been broadly divided into three categories. Let's see what they are. The three categories are supervised learning, unsupervised learning, and reinforcement learning. Now, these differ based on multiple things like the data being fed, the way the algorithm processes the information, etc. Let's talk about each of them in a little more detail. Supervised learning is the most popular paradigm for machine learning. It is the easiest to understand and the simplest to implement. Given data in the form of examples with labels, we can feed a learning algorithm these example label pairs one by one, allowing the algorithm to predict the label for each example and giving it feedback as to whether it predicted the right answer or not. Let's see a simple example. Here, you can see that we have a bunch of labeled data. We have three types of fruits, and each of these fruits are labeled apple, banana, and cherry. This is training data that is fed into the model on which the model is trained. Here, the model by itself tries to learn what makes a banana be labeled as such, or an apple labeled as an apple, etc. Once the model is trained, you can show the model some test data. For example, here we're showing the model a picture of a banana, but we're not telling the model that it is a banana. If the model is trained well, it will output the prediction as banana. Supervised learning is itself divided into two sections: classification and regression. It is a classification problem when the output variable, or the thing you have to predict, is a category, such as the apple or banana problem we just saw, and sunshine or rain, etc. It is a regression problem when the output variable is a real value, such as dollars or weight, or even how much inventory you need to stock in your warehouse. Next up is unsupervised learning. Unsupervised learning is very much the opposite of supervised learning. It features no labels. Instead, our algorithm would be fed a lot of data and given the tools to understand the properties of the data. From there, it can learn to group, cluster, and organize the data in a way that a human can come in and make sense of the newly organized data. Here, you can see the same set of data being fed into the model, but this time we provide it with no labels. The model then discovers similarities and patterns in the data using various techniques and then groups them accordingly. At no point does the system know the correct output with certainty. Instead, it draws inferences from datasets as to what the output should be. So the basic difference between a supervised model and unsupervised model is this. Supervised learning models are trained using labeled data, while unsupervised learning models are trained using unlabeled data. Reinforcement learning is fairly different when compared to supervised and unsupervised learning. Where we can easily see the relationship between supervised and unsupervised, the relationship to reinforcement learning is a bit murkier. Reinforcement learning can be looked at as the model learning from its mistakes. The following diagram will show the typical framing of a reinforcement learning scenario. An agent takes actions in an environment, which is interpreted into a reward and a representation of the state, which are fed back into the agent. Place a reinforcement learning algorithm into any environment and it'll make a lot of mistakes in the beginning. So long as we provide some sort of signal to the algorithm that associates good behaviors with a positive signal and bad behaviors with a negative one, we can reinforce our algorithm to prefer good behaviors over bad ones. Over time, our learning algorithm learns to make less mistakes than it used to.